Hello, you are once again welcome to my channel. So we are going to solve this question today, and this question falls under resistance and resistivity. Please make sure you subscribe to the channel. Okay, so a coil has 10,000 turns of insulated copper wire, the mean length per turn being 150 millimeters, and the area of the cross section is 0.3 millimeter square. Calculate the resistance of the coil, assuming the resistivity of the copper at working temperature to be 0.02 micro-ohm meters. Okay, so what we do first is we write our data down. Okay, so number of turns is equal to what? 10,000. Length per turns is equal to what? 150 millimeters. Area is equal to 0.3 millimeters square, and then the resistivity is equal to 0.02 micro-ohm meters. So we are to solve for resistance. I hope you understand. So we first have to write our data down. So we have the number of turns to be 10,000, length per turns to be 150 millimeters, area to be what? 0.3 millimeter square, resistivity to be 0.02 micro-ohm meters, and we are required to calculate for what? The resistance, which is what? R. Okay, so as I said earlier, if you have not subscribed to this channel, please make sure you subscribe to the channel, okay, and don't forget to share the videos. Okay, so let's move on with the solution. So first of all, we calculate the length. Okay, and how do we calculate for the length? The length is equal to what? The length per turn times the number of turns. So the length per turn is what? 150 times 10 raised to the power negative 3 times then the number of turns, which is what? 10,000. I hope you're following it. So we first solve for the length, which is equal to what? The length per turn times the number of turns. The length per turns is what? 150 times 10 raised to the power negative 3 times the number of turns to be what? 10,000. So when we multiply 150 times 10 raised to the power negative 3 by 10,000, we are going to get what? 1,500 meters. I hope you are following it. Okay, so now that we have calculated for the length, let's move on to calculate for the resistance. So to calculate for the resistance, we use the formula R equals rho L over A. R is what? The resistance. Rho is the resistivity. L is the length, and then A is the area, cross-sectional area. Okay. Alright, so from our data, we have the area to be what? 0.3 millimeter square. We have resistivity to be 0.02 micro-ohm meters, which is the rho. Resistivity is the rho, and it's what? 0.02 micro-ohm meters. And now we have calculated for the length, which is what? 1,500 meters. Okay, so let's substitute the values into this formula so that we can solve for R, which is the resistance. I hope you are following it. Okay, so we have 0.02 times 10 raised to the power negative 6, which is rho, that is the resistivity, okay, times the length L, which is what? 1,500, all over the area, which is what? 0.3 times 10 raised to the power negative 6. So times 10 raised to the power negative 6 will cancel out. I hope you're following. Now 0.02 times 1,500 will give us what? 30 over 0.3. So when we divide 30 by 0.3, we are going to get what? 100 ohms as our resistance. Okay, so thank you so much for watching, and please don't forget to subscribe to the channel. Thank you.